In this video, we're going to look at the difference between the parallelogram rule and the triangle rule of vectors. I'm going to use a worked example to show the difference between the two. Now, looking at the picture, the vectors A and B here have been drawn tail to tail, and the diagonal is the resultant of the two vectors if a parallelogram has been drawn from them. On the other hand, the triangle law of vectors, you have a vector A and a vector B which have been drawn head to tail. So the resultant vector would be the line that closes the triangle. In other words, that joins the tail of A to the head of B. Now, the parallelogram rule itself states that if two forces acting at a point are represented in size and direction by the sides of a parallelogram drawn from the point, their resultant is represented in size and direction by the diagonal of the parallelogram drawn from the same point. So the diagonal is drawn from the same point, that is where you have the tail to tail, where I stressed at the beginning. Now, the thing to note here is that the vectors have been drawn tail to tail. Very important. On the other hand, on the triangle rule of vectors, it states that if two vectors are represented in size and direction by the consecutive sides, that is head to tail of a triangle drawn to scale, then the third side represents the resultant vector in size and direction. So in this one, we are saying that the vectors have been drawn head to tail, as you can see. So the tail of this one is then joined to the head of that one. That would be your resultant. Now, the thing to note here is that the vectors are drawn head to tail. Now, these are the tips for drawing to scale. When scale drawing, first of all, write down the scale, right? Use a pair of compasses and dividers to measure accurately on the ruler. I always do this to minimize random error, that is parallax error that can come from measuring. You also need a protractor for measuring angles accurately. You also need a pair of dividers, that is to measure the resultant. You need a pair of dividers. I'm going to show you how this is done. So I'm going to move straight to the worked example. So in this worked example, we're saying find the scale drawing, find by scale drawing rather, the resultant of two forces, one of 30 newtons and the other one of 40 newtons at 60 degrees to each other. Okay, so we are going to do that. Now, so the first thing to do is to write down the scale. Okay, so we said that our scale is 1:10, 1 centimeter representing 10 newtons. Right, so the first thing you need to do is, again, to use the pair of compasses. Like I said, you measure accurately the 30 centimeters using the pair of compasses. So this way, like I said, it minimizes parallax error, and you get your value of the resultant as accurately as possible. So the ruler here has been graduated in millimeters. So in other words, we're just having 10 millimeters representing 10 newtons. So once you've marked 30, you need a base, the line that you draw, that will be your baseline, from which you then measure the 40 Newton vector as well as the 30 Newton vector. right? So after marking that, you then need to measure the angle 60 degrees. And then you join. So here we are not yet measuring the 30 newtons, just drawing a line that shows 60 degrees. Now we are measuring the 30 and the 40 newtons. So the 30 newton will be as shown. Then this is the 40 newton. Then after that, you then transfer it onto the drawing. Then now to produce an accurate parallelogram, you need to again measure 40 from the point where you have your 30 there on the line that is at 60 degrees, putting your compass point at that particular position, and then you measure 40, you strike or you describe an arc. Then on that line, on the 40 newton vector which you've measured, you also measure 30, and then when the two intersect, that's where you have the two lines accurately. So you then join the two right there. So that one is going to be 30 newtons, and the other one is going to be 40 newtons. So you're going to produce a very accurate parallelogram. So that is 40 newtons, and then the other one is 30 newtons. So remember, our vectors have to have head and tail. So that's head. That's the head of the 40 newton again. Then the diagonal, remember I said the diagonal is the resultant force. So 30 newton ends right there, and then I'm just outlining there, and then I'm producing the diagonal, which then comes to be our resultant. Right. Now, you then measure the length of the diagonal. You use a pair of dividers to do that. This is how you do it. So you open to that, and then go on the ruler above the measurement. You then have the measurement as accurate as possible. So that's 61 newtons according to that. So 6.1 centimeters, which will be transferred to using our scale to 61 newtons. Now, using the triangle rule, remember we said that the vectors have to be drawn head to tail in this one. So I already have my baseline. I open my compass to 40 millimeters, which will be 4 centimeters and 40 newtons. Then I describe an arc right there. Then I'm going to measure the 60 degrees that is between the horizontal and the 30 newton vector. Right, so measuring that, then joining that point and that point. If you want to just measure the 30 Newton right there, so that you don't have to draw all the way to that mark from the protractor. So I'm having my vectors head to tail right there. So that's the head of this 40 Newton vector connected to the tail of that, and that's the head like that. Now remember we said that the line that closes the triangle becomes our resultant. Okay, that's the line over there. And then you are supposed to use pair of dividers now to measure that length accurately. Okay, pair of dividers, very useful piece of equipment. Right, so that there it is. So there it's giving me 60 newtons. Remember with the parallelogram I got 61, and with this one I'm getting 60. In these questions they normally give you a tolerance of plus or minus 1 Newton rather. Okay. Right, so we are saying that we need to have the vectors drawn head to tail on this triangle law, and then tail to tail on the parallelogram law. Now we want to verify using cosine rule. So remember with the cosine rule we need let's see, let's have something on the cosine rule. So the cosine rule, the triangle looks like this. A, B, and C are the sides, small letters at the sides, and the big letters are the angles. So A squared will be equal to B squared plus C squared minus 2BC cos the angle A. Okay, so the angle A is opposite the angle at the side A. Okay, so that's the very same thing that I used here in finding that side. Okay, so we do have we want to find the resultant, so which means that we have this side and that side, the 40 and the 30, so it's going to be 40 squared plus 30 squared minus 2 times 30 times 40 cos the angle A, which has been shown there, which will be our angle 120. Okay, so adding the 2, 40 squared plus 30 squared, then subtracting all that. So then that becomes, since cos 120 is a negative, that's why you end up adding there. So our resultant is going to be the square root of 3700, which is 60.8 newtons. So with the parallelogram we found 61 newtons, with the triangle we found 60, and the actual one by calculation is 60.8. So I think you have seen how accurate using a protractor, pair of compasses, and a divider, how it is. Very, very important. Now if you found this helpful, please do subscribe to the channel and hit the notification bell so that you're notified of my future videos. Right. Signing out.